Hi there, coders and math lovers. Welcome back to CodeNMath with Ramanand. Now, let me ask you something. Have you ever wondered why the best programmers are also pretty good at math? Is it just coincidence or there's something deeper behind it? Well, today we are dividing the hidden connection, the mathematics behind the programming logic. By the end of this video, you will see how secretly powers every piece of code you write, from a simple calculator to the artificial intelligence. So, ready to uncover how math becomes code's superpower? Let's begin. Alright, before we jump to the fun parts, let me ask you a big question. Why does math even matters in coding? When we say coding, most of people think of typing syntax or using fancy framework. But coding is really a blend of logical and analytical thinking, and that's exactly what mathematics trains for us. Math gives a logic structure and make our code precise. Think about it. Every loop, every condition, every formula you write is just math wearing a hoodie called programming. Okay, so math doesn't just help, it defines how computer thinks. And that brings us to the real magic. What kind of math lies behind programming? Let's take a look. Here's the secret sauce. Programming is built on six powerful maths concepts, that is arithmetic, algebra, logic and boolean algebra, functions and relations, statistics and probability, and graph theory. If we talk about the arithmetic, then it is for basic operations and calculations like addition, subtraction, multiplication, division, and many more. If we talk about the algebra, then it's just for handling the variables and the equations. And if we talk about the logic and boolean algebra, then it is just the decision maker behind every condition. Okay, and in the functions and relation, we see the turning complex problem into the reusable pieces of code. And in the statistics and probability, we see powering AI, games, and predictions. And in graph theory, we are just connecting the data and solving the real world path problems. That sounds interesting, right? Now let us uncover how these work inside the code one by one. Let's start with a simple without with something you have been using since your very first line of code, that is arithmetic. Okay, so arithmetic is the heart of the programming. Every time you add, subtract, multiply, or divide, means you are performing the mathematical operations. In this code also, you can see I took the two variable a and b as 5 and 3, and then I did the sum, and further I printed that sum, that result. Okay, that's not just code, it's a pure math. From calculating totals in a shopping app to computing pixels in a game, arithmetic makes your program work smoothly. Now, that's the foundation. But what if we add the variables and formula? That's where algebra steps in. Remember algebra from school? Variables, equations, and that good old y is equal to mx plus c. Well, guess what? It's everywhere in the code. As you can see here, y is equal to mx plus c. These simple lines powers graphics, animations, and even machine learning trends lines. Okay, isn't it amazing how a formula on paper turns into a logic in a computer? That's algebra bringing logic to life. But wait, how do computers decide when to run this formula or which path to take? Let's flip the switch and move into the world of logic and decision making. Every time your program says yes or no, true or false, you are seeing Boolean logic in action. For example, if the age is greater than 18 and is this citizen of India, we can say here is that citizen of India, then system will print that eligible to vote. Okay, then is it simple? Sure. But this teeny piece of logic runs the world, from login checks to the AI conditions. Boolean algebra with and or and not is literally how computers thinks. Because remember, a computer's brain is built on ones and zeros. So that's math at its purest form. Now, decisions are important, but what about the repetition, reusability, and structure? That's where the functions takes the stage. In math, we define functions like fx is equal to x square. Give it a number, get a result. Programming says, hey, I can do that too. So we can say that I took one method which takes the input as x and that return the integer as the result as x square, means x into x. Boom. What? That's math turned into the code. Functions help us to organize logic, reuse code, and simplify the problems. And if a function call itself, that's the recursion, a direct mirror of mathematics definition. But hey, what about the program that thinks, predict, and learn? That's where we meet two of the most powerful friend of coding, that is probability and statistics. Let me ask you, how does YouTube recommend your next video? Or how do games generate random in image? Yep, that's probability and statistics behind the scenes working. Okay, then give your code the ability to predict, decide, and adapt. AI, machine learning, data analysis, random number generation, that all rely on this concept only. When your app says there's a 90% chance of rain, is it guessing? No, it's calculating. Now, we have seen that how math helps our program think. Let us explore how it helps them connect through the graph theory. Have you ever wondered how Google Maps find the shortest route or how Facebook suggests new friends? That's the graph theory in action. One of the coolest areas of mathematics in programming. It deals with nodes and edges, uh, or in computer terms, we can say points and connections. For example, in the Dijkstra algorithm uses math to calculate the shortest path between the 2 points. So the next time map shows how you the fastest route, how map shows you the fastest route, remember math helped you reach your home faster. And now we have arrived at our final stop. Let's wrap it all. So what we have learned, math is not just a subject, it is the foundation of programming. Logic, structure, and algorithm all flow from math. And now, the better you connect the formulas with the code, the more powerful your programming becomes. So, the next time someone says, I am not good at math, then tell them, then let's fix that because math is coding. So, thank you so much for watching my video, and if you enjoyed exploring how math build the brain of programming, make sure to hit the like button and subscribe to Code and Math with Ramanand, and also drop a comment that which math concept helps you the most while coding. Remember, when code meets math, logic comes alive. Until next time, keep learning, keep coding, and keep calculating your success. Thank you.